This is problem number 5 from section 7.5. It asks you to find sine theta over 2, cosine theta over 2, and tangent theta over 2, given that cosine theta is 1/6 and our degrees are between 0 and 90. Now, this is a different formula. Before we had double angle, we had 2 theta for each of these. Now we have half angle formulas. So I'm going to introduce some different forms right up here. Our half angle formulas: sine theta over 2, cosine theta over 2, and tangent theta over 2. The plus and minus just deal with which quadrant you're in. So that, again, we're going to start with figuring out the quadrant we're in. It just so happens they tell us the quadrant. 0 to 90 degrees, we're in quadrant 1. So let's go ahead and write that, quadrant 1. And then we can go through and draw that triangle. Now, we probably don't need this for this problem, but it's just good practice to understand that cosine theta is 1, so adjacent over hypotenuse, and that we need to find this side most of the time and then find our tangent theta and sine theta as well. So I'm just going to do that anyways. How do I find this side? Well, I would say that 1 squared plus x squared equals 6 squared. So I end up with, this is 1, this is 36, so x squared equals 36 minus 1 when I subtract it. So x squared equals 35, so x equals root 35. Okay, root 35 is here. So just like in the double angle formulas, I'll write out my different functions. So I know cosine theta is 1/6. My sine theta is going to be opposite over hypotenuse, so root 35 over 6. And my tangent theta is going to be root 35 over 1, which is just root 35. Okay, once I have these three functions, I'm ready to go. Now my half angle formula, you can see all three of these don't really call for sine or tangent, but there are some alternative versions. It looks like they might just call for cosine as well, but I still just think it's good practice to have those written up there. For this sine theta over 2, we can write sine theta over 2 equals, now it gives us plus or minus. Well, we're in quadrant 1. We know sine is greater than 0 in quadrant 1, and so is cosine. We can write that here, sine greater than 0 and cosine greater than 0 as well. So we know they're both greater than 0. We're going to use the positive versions. So we're going to say that that is root 1 minus 1/6 over 2. We're going to find a common denominator here. So that's root 6 over 6 minus 1/6 over 2, which is going to give you root, that's 5 over 6 over 2. So then I can combine those together, and that'll be root 5 over 12. Now most people are going to stop here, but we can actually simplify this farther. We can write this as 5, so root 5 over 3 times 4. Now 4 we know is a perfect square. So we can rewrite this then as root of 1/4 times 5 over 3. What's the root of 1/4? Well, the root of 1/4 is a half. Root 5 over 3. So that is our answer for sine theta over 2. All right, let's go to cosine theta over 2. So cosine theta over 2 equals, if we look at our formula here, cosine theta over 2, plus or minus, the only difference now is we're adding cosine theta instead of subtracting it. So let's go ahead and say that that is, and we're going to skip a little bit to the 6 over 6 part. So I'm going to say that that's root. Instead of writing the 1, I'm going to write 6 over 6 plus cosine theta, which is 1 over 6 over 2. And that's 7 over 6, but it's over 2, so I'm going to skip a step and say that that's 7 over 12. And the only reason I'm doing that is we just did that right there. So we know it's going to work out the same way with this division of 6, division of 2. And again, we have 12 on the bottom. We could rewrite this as root 7 over 3 times 4, which is root 1/4 times 7 over 3, which is 1/2. When you take the root of 1/4, that's 1/2 root 7 over 3. All you got to do when you're figuring out the root of 1/4 is ask yourself, what times itself gives you 1/4? Well, 1/2 times 1/2 gives you 1/4. So there we go. And so that's our cosine of theta over 2. And now we want to find tangent theta over 2. And this time we take and tangent's also positive. If cosine and sine are both positive, this is positive as well. So we get theta, or not theta, radical 1 minus 1/6 over 1 plus 1/6. Now, long story short here, we already know 1 minus 1/6. 1 minus 1/6 gave you 5/6. So we have 5/6 over, and 1 plus 1/6. 1 plus 1/6 gave us 7/6. So we can say that that is 7/6 the root of. You're dividing two fractions, flip and multiply. So we have root of 5/6 times 6 over 7. And so we end up with the root of, the 6's cancel, 5 over 7. Both are prime numbers. That's the answer.